Hi guys, and welcome to this Model Engineers Workshop. Today in the workshop, let's continue with the steam valve chests. Come on. Hi guys, I'm the chef. Today we're going to continue on with the steam valve chests for the Wombat Loco. So I've got the two on the bench here. Come on, let's have a look and I'll talk you through what we've got to do. Righto guys, so as you can see I did catch up from the last video. So there we go. Left, right, and I even managed to get the corresponding hole in the other end because of course the valve spindle runs through all of these. Even managed to get those in the right place as well, which is a minor miracle. But I did say somewhere along the way that these are handed, one left and one right. So what are we going to do today? Well, in these, I've got to get this right now. There we go. So of course this is the outside of the Loco. It's frame side of the Loco. We've got to put a big hole through here, which is where the steam goes in. And of course, ditto into that one, just handed of course. Then we've got a honking great hole to cut out of the middle here, which is where the actual valve will slide up and down in. And then we've got a lot of more holes to go in. These are just drilled holes, nothing tapping. And we've got a couple of holes to do for the actual valve chest hold downs. I'll go into more details on those when we get there. I'll just keep you in suspense till then. How about that? Righto, guys. Yeah, let's get one of these into the mill vise and we'll keep moving. All right then, guys. See you in a bit. Righto, guys. So we've got the blank for the left hand valve chest in the mill vise now. We've got to drill the big hole for the steam inlet, which is then going to be tapped 1/4 inch BSP, British Standard pipe. Now, 1/4 inch here in the boss we've just finished turning on the lathe to 3/8 BSB, British Standard brass. Now, this we had to bore out to 11.7 for a 3/8 tap. This we're going to have to bore out to 11.6 for a 1/4 inch tap. Now, isn't that just wonderful? Two different taps, two different standards, both using the same size hole. Wonderful. So that means when this is with the cover which we've still got to make and the cylinder block when it's finished, we're going to have millimeter threads, Model Engineer threads, British Standard brass, British Standard pipe. 4 different kinds of bloody threads. And they wonder why, or they keep wondering, that maybe the model engineering hobby is going to die out because it's not interesting to the youth of today. Well, I think I've found one reason for that one. Right, so anyway, it's going to be the same thing again. Going to go center drill, 5, 8.5, 10.5, and I'll get the boring head in and we'll bore it to the depth and the right diameter. So we're going to be going down about 23 so that we get at least clean threads all the way through. Once we get the hole put in the middle, we need to have 15 mil of thread or close enough, 14, 15, for whatever fitting we're going to have to make or buy to go in there. So I'll record this and then I'll speed it up. There's no point you watching all that again. It's pretty much the same as it was on the lathe or even when we did the last hole using the boring head. Yeah, the big hole in the cylinder block. All right, guys, here goes. There we go, guys. That's as far as we go with the drills. I'll set up for the boring head and I'll bring you back. So I've got the boring head into the mill, got the one of the smaller boring bars into it. I've just kind of made sure I'm in the hole, and I've just put on a little bit of a cut, and we're going to go down 25. So we'll just take this slowly with the manual feed rather than the drill handle kind of thing. Right, here goes. It's going to get noisy, guys. I'll do this one, and then I'll pause it there, and I'll bring it back when I'm up to size, which is, I misspoke, it's not 11.6, 11.75 to 11.8. So at the moment, the hole should be, what's the drill, 10.5, but we'll see how we go. I'll make a cut, and then I'll do some measuring and get the hole finished and get back to you. Here goes. Right, I'll just get that measured, and yeah, then we'll see how far we've got to go. Right, I'll bring you back, and when I'm ready to tap, tap this hole, I'll bring you back. All right, guys, see you in a bit. Righto, guys, so I managed to get that out to 11.75, 11.8. That's as close as I can measure it with my Veronese, so that's okay. This is the quarter BSP tap, and as normal, I'm just going to start it, get a few threads in the hole, stop the machine, drop the chuck off, lower the table down, put the tap wrench onto it, and take it down by hand. I don't really want to be tapping a blind hole and bottom this thing out. So here goes. Let's get these first few threads on it, and then I'll change to finishing it off by hand. Here goes. Take the table down. All this does is ensure that, don't need that anymore. All this does is ensure that the threads are started straight and square. Right, let's get this onto the top of here. Tighten that up. There we go. And let's get this cutting and going down. Here we go. Right, as always, as much as it's cast iron, forwards and backwards, can't really say that enough. Just breaks the chips. There we go, we're getting that. 19 threads to the inch with a quarter BSP. And we've got to go down just shy of an inch till the tap bottoms out. The hole went down to 25, so which is give or take an inch. And I'm doing half a turn at a time. I would suggest 38, but of course you've got the lead on the tap. Thought we were there for a minute. We won't be far off. As I was saying, it would suggest 38 half turns. Oh, there we go. So we must have got a couple of good threads on there to start with, because that was nowhere near 38 goes. Right, let's take that out, clean up, and have a look at that thread. Yep, that looks like a nice thread. All right, guys, I'm going to set up for the next job, which will be, what should we do? Should we do all the holes? For the bolt, the studs that go through this, or shall we do? What shall we do? No, let's do the big hole first. All right, guys, give me a few minutes. I'll set that up. Here goes. Okay, guys, so there we are. That big hole over there is at the back here now. This is the frame side pointing towards the frames, of course. I think you can just about make out. I've got some scribed lines on here, just to let me know I'm in the right sort of place. I've got coordinates on a piece of paper out the back. Can you see the piece of paper? No, you can't. A piece of paper out the back with the coordinates for the 4 corners minus the size of this 1/2-inch carbide cutter. Now this should go through cast iron like the hot knife through butter. We will see. Nice and sharp anyway. So I'm going to drill the 4 corners, and then it's just going to be like we did with the ports. We're just going to go up and down until we break through, up and down until we break through, and then we'll go across and go across. It is going to leave a little bit in the corners that will need to be filed out, but I'll do that off camera because there's no point in you watching me filing. So anyway, same system again. We're going to center drill, going to go 5mm, 8.5, 10.5. That will leave me short of the lines because I've taken the final cutter size, 12.7mm. So do this one all the way through, all the sequence, and then we'll go to this one, this one, this one. So I'll show you the first one until we break through with the 10.5. And I'll bring you back when I've got the other 3 done after that. All right, guys. See you in a bit. What am I talking about? No, let's get this one going. Right, here goes. It's going to get noisy, guys. We are probably just starting to break through into that hole at the moment. The one we've just put in the side for the steam inlet. So let's get that out of there. Have to go down a bit further. Are you still going to be able to see? Oh yeah, easy peasy. Right, so let's get this one in here. And there's the jaws, there they are. As you can see, I'm using my new drill chuck. Ozpost finally got the new drill arbor through. Yeah, they had a really bad day, they did. Right, now we should be able to get this one through. I've got this block up on parallel, so we're not going to be pecking into the vise at all. All right, next hole, here we go. Just going steady, because we're going to be breaking through, I think. Yeah, feels like it. Right, I'm through there now. That's it, we're out the bottom. Okay. As I said, I'll have a little bit of filing to do. 1/2-inch carbide cutter. I've already zeroed off. That's fine. When drilling these holes, you've got to be careful because this one, and this one, there's a hole there, and a hole here. So you're breaking through holes and going right through. So you just got to be aware of that. This one was the only straightforward one because that's all just solid cast iron. Right, so I'm going to go in. I don't know how carbide will react to this. It feels really sharp. Running at about 600 RPM. Go down about 0.2, maybe 2.5. And we'll come along to this hole. And we'll see how we go. All right, going to get noisy, guys. Here goes. Yeah, let's do just 1 or 2 cuts together, and then I'll bring you back when we get to a more important part, more inspiring part. Anyway, more exciting is the word I'm looking for. There we go. Right, here goes. Going to get noisy. Right, let's just clean that off and have a look, see what we've got. That was 2 cuts at 0.3. Oh, a lovely finish if nothing else. Right, and we'll bang on the lines. That'll do me nicely. Right, guys, I'll get this one done and that one done, and then I'll bring you back when we start doing the across cuts. All right, give us 20 minutes. Here goes. Righto, guys, so there we go. First 2 cuts are made. They go all the way through. Carbide cutter's holding up really nicely. So nothing wrong with using carbide. Right, so it's the 2 long slots in now. I'm going to do the same again going across here, and then the same across the back end here. Right, so when I get those in and this middle piece has dropped out, I'll bring you back at that. All right, guys, see you again in a bit. Won't be long. Righto, guys, there we go. And the 2 cuts, taken out that chunk out the middle. That has to be a little bit careful because it was getting a bit springy. So I broke that piece out by hand. Can you hear that? There we go. So that's might be a useful little piece of cast iron, but anyway, it'll go in the scrap bin. Might get something out of it one day. Beautiful surface finish. Carbide cutter's doing really well. Okay, guys, going to change this out now for the drill chuck again, and we've got the 10 holes put in like we did on top of the cylinder block, and then things get really exciting. All right, I'll be back in a bit. Okay, here goes. Righto, guys, so here we go. Hole pattern the same as in the top of the cylinder block. 10 holes, 5mm all the way through. So send 0.5mm. I don't know if you can actually see those. They are there, just at the tip of my finger there. And then you got here. Same on that side, 2 in the middle. I've just put some little marks using the center drill onto the cast iron just to make sure that everything is missing all the holes we've already put in this block. And they do. So you saw me doing this on top of the cylinder block. So when I get these in, and I'll whip it out of the vise, take some burrs off, and I'll bring you back. All right, see you in a bit. Righto, guys, so there we go. Quick deburr round, didn't take much. All nice and clean and tidy. 2 more holes to do, and they're quite involved. Blue dot here, blue dot there, roughly in the right places. I'll do it on the DRO, of course, on the mill. Is where those 2 holes are going to go. So I've lined the valve chest up where it's supposed to be, put in some of the studding, and tighten those down, so that's now nice and solid. So when this is in the mill, blue dot here, blue dot there, we're going to be drilling those through with an M3. Yep, that's going to go through to literally 26, because we need a dimple in the cylinder block itself, right? We're then going to go down with a 3.2 for about 16, so 26 with the 3, 16 with this, because we've got some stainless steel 25mm little hex bolts, cap head bolts, to go in these holes. So of course we're going to countersink as deep as we can, down. So that'll take the heads down about 10, which means there's going to be, these are 25. You can see they line up, so that's going to leave about 10mm sticking out the bottom of the valve chest eventually. Get that done on both of these holes. Rip this whole thing off while it's still in the vise, use the coordinates again. Then we go 2.5, which is the tapping size for M3. And then, of course, we're going to tap M3. What do these 2 bolts do? Right, well, they hold this slot still. Because you can imagine you've got 10 nuts and bolts. I've tightened these down so I can't loosen them. You've got 10 studs and bolts holding on the valve chest covers, which we've still got to make. Now, of course, if you need to make any alterations, you loosen off all 10 bolts, whip off the cap, and then basically this is all free and flopping around. The drawings suggest drilling and reaming M3 and using dowel pins. Yeah, no. I saw recently a bloke in the UK, somewhere near Manchester, I believe. She got a YouTube channel also. He's called Mark Chivers, Chivers, I think it is. And he's building a Tinkerbell, which is a very, very large 7.25, really meant for passenger hauling. Sorry, just keep the camera tripod. Meant for passenger hauling locomotive. It really is. It's a big one. It's a lovely locomotive. Quite an old design, very popular, and there's quite a few variations on a theme on that one. His drawings also suggested dowels, and he didn't want to do them either. So he used X-cap bolts. I like that idea. I think that's probably better and more secure than dowel pins, because of course dowel pins, as much as they're supposed to be a good fit, they will allow vertical movement if you take all these bolts out. So it might affect something, I don't know. But anyway, I think doing this, as much as it's probably slightly more involved instead of just drilling 2.8 and reaming 3mm, I've got 3 drills to use, a counterbore and a tap. So slightly more involved this way, but I think because you can actually then tighten them down, it's going to hold all of this still. Doesn't matter, it's got no vertical movement, no twist, no forwards, backwards, no side to side, nothing. Right, that being explained, I'll get this back in the mill over there, and we'll get these holes drilled and counterbored. So, one more time, 26, so we leave a dimple in the cylinder block with a 3mm, We'll then go to 3.2, which is the clearance for the pilot on the counter bore. Can you see that? There you go. That counter bore, that pilot is 3.2. We'll go down 16 with those, so that by the time we run out of the pilot depth, we've gone down 10 mil, which gives us the 10 mil on the bolt sticking out the bottom of the valve chest, which is the 10 mil that will bolt into the cylinder block itself. Once we've done that, loosen these four off, whip this off, drill 2.5, probably to a depth of about 15. There's no point drilling down 10 and trying to tap 10 because you won't make it, and tapping blind holes is a pain anyway. So we'll go down further than we need, and we'll tap as far as we can, and then we know we've got plenty of threads, clean threads, nothing messed up at the bottom that these bolts are going to reach. Okay guys, that being said, I'll get off over there towards the mill, and I'll bring you back when I'm set up and we're ready to go. See you in a bit. Righto guys, so all set up in the mill. Smaller center drill, not the great big chunky one we've been using, a little tiny one. And so center drill, 3 mil, 3.2, so 3 mil to 26, 3.2 to 16, counter bore as far as it will go. Then move across to the second little blue dot, which is in the back here, and do the same. Then we whip this whole block out, this whole valve chest off, go back to the coordinates, and we use the 2.5, go down 15 or so. And sorry guys, I've just realised I've got a Huntsman spider on the wall. It's a big one. So we'll go down 15 and tap as far as we can with the M3, just to make sure we've got plenty of threads to go at. That's probably a 3.5 inch, so let's say a 100 mil spider on the wall. I wonder if I can just get you. I'll just move you around. It's going to be a bit bumpy, guys. Okay, here goes. Let's have a look. Where is he? Okay, hang on. Let's just loosen you all up. There he is. Can I zoom in a bit more for you? Yeah, there you go. Honking great Huntsman. All right, let's get this put back where it belongs. Fortunately, he's not moving. He's quite tame. I'll look at him. Right, okay, there we go. I'm on the wrong side of that handle now, so there we go. Let's just reset you again. No, you're not looking too bad. Square you up a bit. There we go. Yeah, that'll do it. Right. Yeah, let's get this done, guys. Here goes. Gonna get noisy. So, there we go. That's the centering. Get us started. Let me just double check this drill to make sure I've got the right one. Yep, this is the 3 mil. And I'll use the depth stop on the mill, or the graduations on the hand dial anyway, to down a little bit more. Doing the 3.26 mil rather, so I'll just again, just doing this till it just drags. 26 is going to give us just a millimeter dimple into the cylinder block itself. There we go. Did I tighten that up, guys? Sure did. All right, here we go. Going to be pecking at this quite a bit. Here goes. That's to the depth of the center drill. Just a couple of mils at a time. Clean that drill out. Got about 10 to go. And as I say, that will just put a dimple. in the cylinder block for us to pick up on later. Six to go. 5, 4, 3, 2, and we're getting very close to the bottom end of the valve chest now, on the top of the cylinder block. Here's the last one going in now. 26. Okay. This one comes out. Go to the 3.2. Just lost my piece of paper. There we go. Put that back where it belongs. This one in place now. Oops. Put it down a little bit more. There we go. Now, this one needs to go down 16. So again, piece of paper is what, 4 thou thick, 5 thou, so it's not really going to be desperately inaccurate, but it's quick and easy. Just till you can, oh, a little far. Just till it starts to drag. Oops, there we go. Like that. What did I say we needed? 16, wasn't it? Oh, righty, that's it. Here goes. Again, just pecking at it. Gently, gently. Yeah. Obviously a 3mm drill's bigger than 3.2. There we go. That's as far as that needs to go. Right, let's whip this out. Let's see if the pilot from the centre board will actually go into that then. It certainly looks like it will. Oh, yes, that'll go. Okay. Alright, here goes. Let's give this a go. Now, of course, I can set this quite accurately now, because I can just bring this down. The pilot will go into the hole. Right there. I know I need to go down 10mm. Okay, here we go. Right, again, just going to peck at it very carefully. That's 5mm so far. Seven, 8, 9, that's my 10. Okay. Kill that so you can hear me better. All right, guys. Right. I'll move over to these coordinates now, and when I get that done and I've got this valve chest off, I'll bring you back. All right, guys. See you in a few minutes. Righto, guys. So as you can see, little dimple there, little dimple in there. So I can just bring the drill down, set the depth gauge, or rather just note which graduation on the handle we've got, and set that. And I'm going to go 15, 16 deep. It doesn't really matter, as you can see here. There's nothing there. There's lots of meat. Same on the other side. So, even plenty of clearance. You see that? Where is it? Too far. Here we go. Went to the little M3 tap. And of course, being so small, I'll use my small tap wrench. There's no point using the big one on this. Right, let's get this done. Yep, easy as that. Okay, here goes. Again, be pecking at it because you don't want a small drill to clog and snap off. Here goes. That's 10. That's 14, one more to go. Just taking the time. There we go, that's 15. Right, let's change this out now for the tap, and we'll readjust the machine and everything. And slow it right down. Use the machine just to get this going and get it in going square and vertical. Right, down into low gear. Drop the speed right down. I know it's cast iron and a spiral tap. A little bit of tapping compound. Won't do any harm. Right, here goes. I'm going to have my finger on the stop button, so once it gets a good start, I'll be stopping it and then loosen the chuck off. Here goes. We're cutting. That'll do. Let's just loosen that off. There we go. Drop the table a little bit more, just so I can get the tap wrench onto it. There we go. And let's just get this threaded. Spiral taps, you don't really need to back off, but it's just force of habit, really. When I first started doing this, I'll be many years ago, spiral taps, as far as I'm aware, were not available to the general public. They were only probably in manufacturing, even if they existed at that time. I don't know. Leave a comment if anybody knows when the taps became fluted instead of just like the ordinary straight tap. That would be interesting to know, actually. Anybody out there with that kind of information, yeah, leave me a comment. I'd like to hear that. I'll pass it on when I get it, and it could be interesting to all of us. You can see, because this is such a small tap, I am applying downward pressure as well at the same time as turning, just to make sure that we're not going to start backing out and stripping threads. I must be getting close. We're still going. That's the advantage of a spiral tap, is that it does evacuate the hole instead of... Oh, here we go. There we go. Think. We're still turning. Oh, that'll do it. There it is. Yeah, they evacuate the swarf chips, whereas a straight flute just lets them drop down to the bottom of the hole. So this is why tapping blind holes... There we are. Take that off now. Can I turn that by hand? No, I can't. That's why spiral taps are, some would say, superior to a straight flute tap. That's going to be a nice hole. Right, now there we go, it's starting to spin. Right, let's get this off here. Get that out of there. There we go. I can see a thread in the bottom in that hole. Love it. Let's get one of the little bolts. Okay. Let's have a look. Yeah, that's going to go nicely. Oh, yeah. Yep, quite nicely, quite tight. Oh, that's lovely. Righto, guys. I'll get the second one done, and I'll bring it back and we'll put them together. All right, see you in a bit. Okay, guys. That one you saw. This one I've just done. Don't know, let's have a look. Can you see counterbore in that one? Yes, you can. There you go. Those are the ones. So this one and this one, I've had the counterbores put in. Let's just check that these bolts pass through. They do. And as you can see, if I get this in the right place and it focuses, yeah, just about there. You can see they stick out quite a nice little bit out the bottom. So let's line this back up again, and get those two. Yep, that lines up now. There we go. Get these. Look at that, nice and easy. There we go, going down, 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 down. I'll turn it all the way there. I'll tell you what, let's wind up back out the other side of it so I'm not fouling with the chuck. Can you still see? Yes, you can. Right, here we go. That is biting. Yeah, that's going down there. A little bit more, maybe. There we are. That one's almost tightening up. We're almost there. Let's tighten this one up as well. A bit more. Okay. That doesn't want to go any further. I might need to just shorten the bolts. I did go down as far as the holes would allow. The tap, rather. This one is still going. Oh, yeah, I'm going to have to shorten the bolts a little bit, but you get the idea. Right, so, I'm a little bit disappointed in that. I thought I'd have gone deep enough. I went down 10, 15, 20. Yeah, should have done. Should be, unless these are 30s on the little bolt. Right, I'll get those shortened shortly. I've got number 2 of the valve chests to do, and when I've got that done, I'll bring you back. Okay. See you in a bit, guys. Not long for you, but a bit longer for me. All right. See you in a bit. Okay, guys. So there we are. Got the right-hand one done. Just tightened up the little hold-down bolts, the M3s. These 2 here, I did shorten these. So that's all nice locked down. And just for the fun of it, I've just put the threaded rod in, which will eventually hold down the next job, which is going to be the valve chest covers. Fairly straightforward job. Shouldn't take too long. But 2 to make, of course. Righto, guys. Give us a tick, and I'll be right back. Righto, guys. That'll bring this video to a close for today. Making some real progress now, as you just saw. The valve chests have gone onto the cylinders, just temporarily, of course. They're going to have to come off again. The next job's going to be the cylinder covers, the little lids that go on the top, but they're just plain flat pieces of cast iron with a lot of holes in them again. So, real progress. So, I'll bring this video to a close, sound like I normally do. If you can find it in your heart and soul, give me a like and subscribe. If you've got this far, think about subscribing. Please, watchers, think about hitting that like button. It's the like button that really counts. The likes put this video in front of other like-minded people. It's those that really count. And just your viewership just makes me want to get back out here again. All right, guys, this is the chef saying, see you later.